So linear is where we're going with this. So a linear correlation coefficient. So when I'm talking about this R value, because that's a variable that we're using, that is in reference to the sample. So we're really talking about our sample. All right. Rho, which is looks like a P kind of, that's our population, but we're not really going to talk in terms of that. We are going to be working in R because this is our sample that we're going to be looking at. Okay, so a linear, meaning a line, correlation coefficient is a measure of the strength and direction of the linear relation between two quantitative variables. So we're back to that, two quantitative variables, right? So it's how do these relate with each other? That's our goal. That's a correlation coefficient. How do they correlate? How do they relate? So here's the key to this one. It is always, always, always between, here, and I got too excited about it because I got this less than or equal to, between -1 and 1 inclusive. All right, between -1 and 1. So that's how it's always going to be between that. So if it's a bigger number than that, it's not going to work. Now let's talk about these words, strength and direction. Strength means how tight is the data. How, oh my, try again. How tight is the data? How close is it together? How strong is this together? How much is it bound together? How weak is it as it's pulled apart? That's what I want to know. All right. And the direction is going to give us the slope of the line. Is it going to be positive or negative? And that's why we have a -1 and a +1. That tells us our direction with positive and negative. All right, now look at these examples, and we're just going to talk through these a little bit here because it's obvious of what we have. If I have the slope of the line and it's going uphill, is that a positive or a negative slope? Positive. And the tighter this is to an actual line, the closer this is to 1. And so that's the key. So the closer it is to 1, then, or -1, I'm going to come over here to this part D here real quick so you can see as tight as the data is. If it basically is in a line, then that's a perfect negative correlation because my slope is negative. That's what makes it -1. My slope is positive. That's what makes it +1. All right. Then as close as these data points are to that line, the closer it is to 1. Now, if they're going in the upward direction, these are kind of upward direction, then that makes that positive. This is kind of a negative direction, Then that's what makes that negative. That's all the positive and negative. You're looking at the slope. How tight they are and close they are to making an actual line, that's the closer it is to 1. The farther apart it is from that line, the farther away it is from 1, right? So the closer it is to 0, which is no correlation, right? No, linear. Linear is the key. This is a linear correlation. Even if it has a graph, but it's non-linear, there's no linear correlation. I'm still close to 0. All over the map in Crazy Town, no linear correlation, close to 0. Kind of close together, but in the negative direction. It's negative, but kind of low. Here, closer to the point, but in the negative direction, it's a -9. Do you see where I'm getting at? -0.9, sorry. Has to go between -1 and 1. So you're looking at two things. How tight is the data for the strength, and is it positive or negative with the direction? Okay. So when we do this, we are going to use technology and StatCrunch in particular, all right, which is why this one's on my computer because I want to show you how to use StatCrunch. The same thing is happening here that happened previously. So in the corner of your data, you're going to have, in my math lab, or my stat lab, you're going to have that little double box. When you click on this, that's where it opens up that menu and it'll say open in StatCrunch. Will be the first option. Crunch, right? You get the idea. Open in StatCrunch, and then it will automatically populate the data in StatCrunch, which is, lo and behold, oh, what we have right here. Ta-da! So I already put this data in to StatCrunch so that you can see what's going on here. All right. So with this data in there, where everything that we do in this class is going to be based off the word stat. Everything is coming out of stat. StatCrunch does a whole bunch of other stuff, but we're not dealing with that in here. We're just hitting this elementary statistics, right? Basics as we're learning towards this. So that's where we're starting. Now, whenever I'm looking at this correlation coefficient, we're also talking about the regression. And in particular, this is linear regression. So we're just taking it simple style. So stat, regression, simple linear. All right. And then you click on that. Now, as we're going through this, your X variable is var1 because it has whatever it's labeled. And because I didn't change the names of it, it just says var1. And then this is var2. Let me scoot this up here a little bit so you can see it better. I didn't realize it was off my screen. And then you don't have to mess with anything else, nothing else. All these options are for other things. We are only inputting this X and Y variable, then you click compute. And when you click compute, look at this right here. It even says correlation coefficient. All right, it says it right there. The rest of this stuff we'll talk about at a different time. But for right now, we just want to focus on the correlation coefficient, and it's up here in this simple linear regression results. So that's the value that you're going for. So our linear coefficient is going to be 0.9386. Right? And we're actually going to just take this over here to 3 decimal places and we'll go from there. So I'm going to scoot this over. Then I'm going to bring my iPad screen back in here. And then I want to write this out because I want to make sure that you see what's going on here. This is StatCrunch steps. Your StatCrunch steps are, you're going to go to stat, and then regression, and then simple linear. All right. Okay, and then R is what we're going for. And then so we're coming back up there. It's 0.9386. So 0.9386. If I round that to 3 decimal places, that'll give me 0.939. Now, think about this for a second. Is this going to be a positive or a negative regression? Positive, right? Because my correlation coefficient is positive. So that tells me my data are all clustered together going up in that positive direction. Now let me fling back over here to the previous page just for a second. Here is that data. Look at what's happening. If I were to put a line through here, look how close that data is to that line. Pretty close, right? So the 0.9, whatever it was, 939 that we had, that makes good sense. And what is my slope? It's going up in the positive direction. So the correlation would be positive if I run a line through there. It's going to be really close. That data is going to be clustered together really close. So this correlation coefficient makes sense. All right. Now I would like for you to try this in StatCrunch because this will give you a chance to look at it. You can get into StatCrunch from any of your homework problems. Just pull it up on your screen, right, while you're watching the videos, and then you can try it out and make sure that you're good to go so that you can practice it in your notes so you'll be prepared in your homework. All right. Good job, guys.